In this video, we're going to look at what is a simplified fraction. Let's read this definition. I'm going to get a highlighter ready. The simplest form of a fraction is the equivalent form of the fraction where the numerator and denominator are written as integers without any common factors besides 1. So that was a mouthful. So we've seen that equivalent fractions in the last few videos. So now the one that's going to be in simplest form is basically when you divide out by the largest number you can, so the numerator and denominator no longer have any common factors. You'd have to turn them into fractions if you divided any further. Okay. Now, something about the language that we use. We may also request that a fraction be written in simplest form by using the equivalent language. So, as math people, we created 80 ways to say this. Well, really 4. To simplify the fraction, we'll say reduce the fraction, or we'll say reduce the fraction completely. All of these mean the simplest form. So sometimes people will see the directions to simplify the fraction, and they'll divide out by some factor they see, but they don't simplify it completely, which is what we mean by the simplest form. So let's look at an example to get a feel for what a simplified fraction is. So write the fraction number for each diagram below the figure using one circle as the unit. So you should be very good at this by now. This is broken into 2 pieces and 1 is shaded. So 1/2. This is broken into 4 pieces and 2 are shaded. So 2/4. 1, 2, 3, 4, 5, 6 pieces. 3 are shaded. 3/6. This has 1, 2, 3, 4, 5, 6, 7, 8 pieces and 4 are shaded. So 4/8. Now we're asked, what do the fractions have in common? Well, notice all of these fractions are equivalent. All of the fractions are equivalent. Okay, so they all represent the same relative amount, 1/2 of the total unit. Okay, they're just broken into a different number of pieces, so they're in a different form, but they're all the same amount of area shaded. Now here's a question. Take a second to think about it before you listen to my answer. Which fraction do you think is the simplest and why? So I would say, and mathematically we will say, that this fraction, 1/2, is the simplest. Is the simplest. And the reason is because it's in the smallest number of possible pieces without having any fractional pieces. So 2/4, this can be grouped into 2 pieces. Okay, and these aren't too hard to understand, but for example, another equivalent fraction is 501 over 1002. Okay, this is actually equivalent to half. I found that by writing a number and then doubling it. Okay, but this is kind of hard or difficult to conceive of. It's hard to think of something broken into 1002 pieces. Okay, and then having 501 shaded, but if you think about 1/2 of them being shaded, it's a lot easier to think about it. So 1/2 is the simplest because it uses the smallest numbers possible. Let's look at the next question. In D, we're asked to divide the numerators and denominators of the second and fourth fractions by 2. What do you notice? So here's the second. The second was 2/4. And we're asked to divide the numerator and denominator by 2. 2 divided by 2 equals 1. 4 divided by 2 equals 2. Okay. The fourth fraction was 4/8. And we're asked to divide the numerator and denominator by 2. 4 divided by 2 is 2, and 8 divided by 2 equals 4. So you can take a second and see what patterns you see here. Okay. What I'm noticing is that 2/4 simplified to 1/2 in one step. Okay. And 4/8, when we divide it by 2, simplified to 2/4. But we also know 2/4 can simplify to 1/2. So what I'm seeing here is that in several steps, 4/8 simplifies to 1/2. Also, 4/8 is equivalent to 2/4. Okay, and there's a lot of things you can see here. Okay, so if you saw something else, feel free to write it. Also notice we could have divided 4 and 8 by 4, and it would have immediately simplified to 1/2. Okay, so the way we did this in 2 steps, 4/8 simplified to 1/2, but that's not the only way to do it. Let's look at the next question. Rewrite the last 3 fractions below by writing their numerators and denominators in terms of their prime factorizations. Do you see any patterns? Okay, so we had 2/4. Now, 2 is a prime number, so its prime factorization is just 2, and 4 is 2 times 2. Okay. The next one was 3/6. Well, 3 is a prime number, and 6 is 2 times 3. Now, the last one is 4/8. 4 is 2 times 2, and 8 is 2 times 2 times 2. Okay? So I didn't make the trees for these prime factorizations, but you can if you need to. And now let's look for patterns. Okay. So what I'm noticing is that for each fraction, okay, the numbers on top, or in the numerator, match the numbers on bottom, except the numbers in the denominator each have one additional 2. One factor, extra factor of 2. So, and again, if you see something else, just write it. Denominators have one more factor of 2 than the numerators. Now let's look at the last question. Simplify your fractions in part E by canceling out all of the common factors besides 1 that the numerators and denominators share. Okay, so when we were simplifying fractions before, we actually did simplify some fractions. We divided the numerator and the denominator by a common factor. So let's look at this. We're going to look at this in a new way. So with 2/4, we could divide both the top and the bottom by 2. 2 divided by 2 is 1, and 4 divided by 2 is 2. And we can get an equivalent fraction, and this is actually simplified, or simplified completely, because 1 and 2 have no common factors besides 1. Now I'm also going to write this up here, this new way we may simplify fractions. I'll do this with a red pen. Now notice we can cancel out factors of 2. So if there's a factor in the numerator and the denominator, we can cancel out the common factor. And this is basically the reason, because we're basically just dividing them into groups of 2. If the top number multiplies it by 2 and the bottom number divides by 2, well, we can just skip that and it simplifies to just 1/2. So, but notice when we do that here, it looks like there's nothing left on top. And when that's the case, you're going to think of this as multiplied by 1, because there is a number left on top. 2 divided by 2 is 1. Okay, so the denominator doesn't come up to the top. Okay, so whenever all of the factors in the numerator cancel, the remaining factor is just 1. Okay, so looking here, we'll do this the division way and then we'll cancel. 3 over 6, well, we'll divide by the common factor of 3. 3 divided by 3 is 1. 6 divided by 3 is 2. Or we can just cancel out the common factors of 3, and what remains is 1 over 2. And I actually never wrote that here. So cancel out the common factor. If nothing remains, put a 1, and then write the final product. Okay. And the last one, 4 over 8, we can divide by 4. 4 divided by 4 is 1. 8 divided by 4 is 2. Now here, notice 2 factors of 2 cancel in both the numerator and denominator. We're left with 1 on top and 2 on the bottom, out of a little bit of room. And notice that leaves us with 1/2.